Hey there, algebra. We're going to spend one more day on lesson 10.5 today just to make sure it goes smoothly. A reminder that the Pythagorean theorem is this, right? And we're using this to solve missing sides on a triangle. I'm literally just going to do a couple right out of your work today to get you going and make sure it's going okay. Let's do number one. Number one is a squared plus b squared equals c squared, right? So if I put in a squared, either of the legs is fine. 72 squared plus 21 squared equals c squared, right? 72 times 72, feel free to use your calculator, I am too. We pop that in and we get 5,184. 21 times 21 is 441. So if I add those two together, 5,184 plus 441, I get 5,625 equals c squared, okay? And then remember, to solve, we can just square root both sides to get rid of that square. 5,625, the square root of that is 75. So we get 75 equals c. So there's our missing side. Notice there's no units or anything or feet, so we can just leave it as 75 today. Let's do one that doesn't have the hypotenuse missing. So notice number 2 right here. We've got a leg missing, so just want to do one like that. So let's just, we'll call that missing leg A. Doesn't have to be, but we can make it that way. And then 15 squared, I believe, is 225. Just double checking my math. Yep. Plus 225 and equals c squared. So 39 squared, 39 times 39, 1,521. Okay. All right, so now we want to solve for a. So remember, you always want to move everything away from your squares first, okay, before you try to do your square rooting to solve. Taking away these two numbers gives us 1,296. So we have a squared equals 1,296. So we square root both sides. And we end up with a equals 36 for our final answer. Hopefully that's making some sense yet from yesterday. So in this bottom section, remember, you're just going to check if these sides could make a right triangle, and then whether or not they form a Pythagorean triple. Now, for most of them, the answer is the same. If it can make a right triangle, then it's a Pythagorean triple. That's going to be a little bit different on 12 and 14. I'll explain that when we get to those. So let's do a couple examples of the first ones first, right? So again, we're using that Pythagorean theorem equals c squared. Okay, and so let's put in all these numbers for number 7. Let's check if this is a Pythagorean triple and a right triangle. So 49 plus b squared, and that's 576, 24 times 24 equals c squared, 25 times 25, which is 625, okay? If we add these two up, does that equal 625? 49 plus 576 equals 625, so sure enough, it works. So you're going to say yes, it's a right triangle, and yes, it's a Pythagorean triple, okay? So most of them, if they're yes, they'll be yes for both, or no, they'll be no for both. Where that's going to be different is on these last two. So let's do one of these together. I just want to explain why that's going to be different on these last two, okay? So either put yes, yes, or no, no for all of them, and then when you get to 12 and 14, watch out. Let's do 12 together just to show you one example of these. So this is a squared plus b squared equals c squared again, right? A squared is 25, b squared is 49, right? Equals c squared, the square root of 74 squared. Notice 25 plus 79 does equal 74, and then this just cancels out. So notice this works. So yes, this could make a right triangle, but is it a Pythagorean triple? If you type in the square root of 74 into your calculator, go ahead if you want. You're going to get this never-ending number. It goes beyond what your calculator can even show. So for that reason, we can't ever write it out as a true Pythagorean triple because it's a never-ending repeating decimal that just goes on and on and on. So for that reason, even though it can be made into a right triangle, we're going to put no for Pythagorean triple. Number 14 will be very similar to that too. So you may always put the first answer being the right triangle because that's what they ask about first, right? And the second answer, yes or no, being the Pythagorean triple. Again, for the first 11, and in fact number 13 too, it's going to all be yes, yes, or no, no. But for those weird square root ones, you can't ever write out some of these square roots because they're repeating decimals as a Pythagorean triple. So for that reason, even if it works as a right triangle, test out number 14, you'll have to put no for the Pythagorean triple part. Hopefully that makes some sense. Otherwise, I think it'll go really well today, guys. You had a good start with this yesterday. I think you'll do well again today. Have a good rest of your day.